Hi, my name is Brady, and this is going to be a detailed explanation of a cybersecurity lab hosted on Hack the Box called FACT. Now, this is going to differ from a traditional walkthrough in that my goal here is not just to go through the machine as quickly as possible and to show everything from point A to point B, but I'm going to be covering each concept that we come across in the lab as though you are a cybersecurity beginner who's never covered any of these concepts before. So, with that being said, we might not necessarily be going through the box completely in order. I might come across some things that I say, hey, we're going to talk about this later. So, if you're trying to avoid spoilers, I would recommend checking out a different walkthrough video that is, again, a little bit more point A to point B. And with that being said, I will be giving timestamps in the video description. So, if we're going over something that you already know, feel free to skip ahead and get to the next part, or use the timestamps in the description to skip around. All right, with all the disclaimers out of the way, let's go ahead and hop into the machine itself. So this is what the lab platform looks like. This is Facts on Hack the Box. So I've already spun up the machine just to save us a little bit of time. But all that the Hack the Box platform gives you when you start is an IP address. So we can just click this to copy it to the clipboard. I'm going to open up a notepad style platform. This is called Sublime Text. And I'm just going to put this in here just so that we have it later and we don't have to keep coming back to this Hack the Box page. So now that we know what our IP address is, we're going to go ahead and jump over to a terminal-based application. So the one that I'm using here is just the built-in terminal in Kali Linux, which is an operating system that's mostly used for penetration testing and cybersecurity uses. And to find out what's going on with this IP address, we can use a tool called Nmap, the network mapper. So Nmap is a tool for network-based discovery, but we can also do some host-based discovery with it. We're going to supply the IP address, which I'm using Control-Shift-V to paste in. And we can just run this tool by hitting the Enter key. And this will go ahead and run for us. And you can see here that it returns some information about some ports. So we can see a port 22 and a port 80, which are both shown to be open. And it tells us what service is typically running on that port. In our default scan configuration, it's just going to be guessing, okay? So port 22 is typically the port for SSH, or Secure Shell. So this is a program that you can use to get a terminal, kind of like the one that we're using, except for instead of the terminal being used to run commands on the machine that we're on right now, we're going to be using it to run commands on the remote machine. The other one here is HTTP, the Hypertext Transport Protocol. So this is a web protocol that we use to view websites, okay? So this is almost certainly going to be a web server. But if we wanted to find out some more, we could throw some options to Nmap. So I'm going to use the up arrow key to bring back my previous command. You can scroll through multiple commands if you've got them in there. But I'm just going to use the up arrow key to bring back the most recent one, okay? Now we can supply what are called flags to Nmap. We're going to use the hyphen character or dash, or some people will call these tacs, and we're going to provide it with some flags, okay? So the one that we're going to use is the tac S capital C flag. And what this is going to do is it's going to run some default scripts against these ports that it finds, and it's going to tell us if anything comes back, okay? Another flag that we can use is the little s big V. So this is for service version enumeration. So instead of just guessing what these services would actually be called, it can actually go in and do some checks and tell us what information comes back, okay? The nice thing about Nmap is we can actually squash these two commands together. So we have the little s for scan type, and then we have the big C for scripts, and then big V for service versions, all right? I'm going to run this here, and it's going to take just a little bit longer to come back than the default Nmap scan did. And that's because it's doing those extra checks in the background. So we're going to have to wait just a second. All right, so I went ahead and jump cut there just to save just a few seconds in this video. And you can see now we have a little bit more information. So we can see that our port 22 has a program called OpenSSH, and this is our service version. We can see that it's running on Ubuntu, which is another Linux-based operating system. And then we have some information about our web server here. So HTTP, we can see it's running on Nginx 1.26.3. Now from here, what we can do is we can scan more ports. We're only scanning the default right now, so we're only looking at the most common 1,000 ports by default. But in this case, we actually have enough information to get started with the machine. So we don't really know what we can do with SSH quite yet. SSH is a protocol that you usually need some sort of credential material to authenticate with. But web services, you can typically log on just like you're logging onto a website, okay? So I'm going to go ahead and grab our IP address. We're just going to go back to our web browser here. Firefox is the one that comes default with Kali Linux, so I'm going to be using that one. Any other one that you have is just fine, okay? And there are a couple of ways that we can access this web server using our web browser, okay? So the first thing that we can do is we can just dump our IP address in. Another thing that we could do is we could provide what's called the HTTP scheme. So we'll say HTTP:// and then we'll visit this site. What we can do, because the web browser uses HTTP by default, is if we just enter our IP address in here, it's going to enter that scheme for us automatically. This is going to take just a little bit of time, and we're going to get an error here. So we can see that the web server is erroring out. It's saying we can't connect to the server at facts.htb. And in fact, you can see that our URL up here, the Uniform Resource Locator, is also going to change to say facts.htb. Now, why is this? Let's grab another tool here. I'm going to rename this terminal and just call this nmap. And then I'm going to open another one there. So we can use another network tool called curl. And this tool is mostly to interact with web services, okay? So we can use the curl command to see what our web browser sees. We can use the tacv command to get a little bit more verbose output, okay? So I'm going to run that. We can see that it tries to connect to port 80, remember, because this is the default port for HTTP. It's going to establish its connection. And then we're getting this request completely sent off. So 302 is going to be an HTTP response code for some sort of redirection. We can see that it says moved temporarily. And then the location down here is that facts.htb. So what the web server is saying is when anybody visits this IP address on port 80, it's going to redirect to this http://facts.htb website. Now, the issue that we're running into here is that this .htb is actually a non-existent top-level domain. So there are different parts of the URL here. So we have our scheme, we have our host name, and part of the host name is going to be this top-level domain, okay, the TLD. And that's just going to be the last part of the host name. Usually you'll see something like a .com or a .net. And we can actually check all the TLDs that are valid. We can go to a website called ICANN. Oops, that's UCAN. Let me type better. ICANN, TLDs list. It is hard to make a video and type at the same time. Okay, so the Internet Corporation for Assigned Names and Numbers, or ICANN, has a list of top-level domains that we can view. So let's go ahead and click into it. And you can see here, these are all the possible valid top-level domains. So if we Control F to find things in the page, we can search for things like, this would be .com. We can see things like .net, .edu if you're going to school. My website is a .tech. So these are all the valid top-level domains. But if we look at HTTP, you can see that we do not get any results. So HTTP is not a valid domain. Let's go back to our terminal and talk about what the reason for that is. In a website that is on a cybersecurity lab, we don't really want to be attacking something that actually exists by accident. So often cybersecurity labs will use these non-valid top-level domains so that we can make sure that we're attacking something that is only in this lab. So the issue here is actually in the way that websites are resolved. So when you navigate to a host name, the host name doesn't actually do anything. The only thing that serves the website is the IP address. So IP addresses are actually how networks communicate with one another. The issue is that humans are not very good at remembering numbers like this. So it's kind of like having to remember everybody's phone number instead of having them saved in your phone or having an address book. So instead we have what's called the domain name system, or DNS, which will let us take a host name like this one, and it'll automatically in the background resolve to an IP address that corresponds with the host name that we're using. Now, the issue here is that because this is not a valid resolving name, when we go out to DNS and say, hey, what's the IP address for this? It's not going to have an answer for us. And what we can do instead is we can manually tell our system to resolve this host name to our IP address. So that anytime we view facts.htb, it knows that we want to go to this IP address. So typically operating systems will have what's called a hosts file. And this file is going to be what our operating system will check before it goes out to DNS to see if we already have a mapping for it. I'm going to use Sublime Text. I'm going to open up. This is in our etc. directory. I commonly call this Etsy because my wife shops online. So Etsy hosts. And you can see we have some mappings in here already by default. So we have one to this local host thing. We can have one to Akali is the name of my machine's host name. And it has the corresponding IP addresses here. So if we tell it to ping localhost, so ping is a network tool that just tells us if we can connect to something. So we will ping localhost. And what's happening here is it's actually pinging an IPv6 IP address. We want it to ping the IPv4 IP address, but sometimes it'll prefer IPv6. So I'm just going to add a little hashtag mark here, or an octothorpe, if you will. And this will just tell it not to look at this. And I will save this, just put in my password so it knows that I can do that. And now if we ping localhost, it's going to be pinging this 127.0.0.1 IP address. Now, this is a special IP address, and localhost is a special host name. This just tells the machine to talk to itself, okay? We'll talk about that a little bit more later as it comes up. But for now, I can uncomment this. And then we're going to create a mapping for our machine, okay? So we'll take our IP address, dump it in there. You can either do a tab or a space. I prefer to do a space here because if I do a tab, it might actually change it. It looks like it doesn't in this case. Awesome. But sometimes if I do a tab, it thinks I'm trying to auto-complete something. So spaces and tabs work just fine for your hosts file. And then we're going to have our host name. So if we go back to, where is our curl? Up here. If we grab this facts.htb, we don't need our scheme because we want it to resolve no matter what protocol we're using. So we'll just say facts.htb exists at this IP address. So I'll save the file. And then if we try to ping facts.htb, you can see that now it's pinging our machine's IP address and we're getting responses. Okay, so this is working properly. If we come back to our web browser now, we can get rid of ICANN. If we refresh this, you can see that now we'll be able to navigate to this facts.htb site. So that technique where you have to resolve the hostname manually is a technique that I've seen most commonly on Hack the Box, but some other cybersecurity ranges will do that as well, okay? So just be on the lookout for that. So now that we have our website, we can actually move around and kind of see what's going on here. So we have this facts site, discover amazing trivia. So we can go around and click on some stuff. So we'll click start exploring. It takes us to this fact about a bear being ejected from a jet. So that's fun. We have comments here. Now, something to note is as you start to train your offensive security instincts, if you will, you should notice these usernames might be potential targets. So if we need to figure out how to get into one of these accounts, now we know what the username might be, okay? But this is just a comments page. We have, let's see, there's another link here for page. So I'll go back to here, and this looks like a listing of all the different pages they have on here. So let's do dolphin fact just for fun. The fastest dolphin can swim 33.5 miles per hour. Cool. Yeah, cool. We have other comments, but let's go back to our page here. So as you clicked around the website, you might notice that our URL here at the top is actually changing. So not only can we navigate by clicking the links on the page, we can actually navigate by changing the URL. So if we do, I think it was animal. Yeah, it fills it in for us. Nice. Animal ejected. You can see that we're able to navigate to that page without clicking any links, okay? If we go back to page, we can come back to the page listing. So this is useful when we want to find things that might not be listed in hyperlinks on the page. There are going to be some valid parts of a web server that you can access by URL, but not by page links. Now to find one of those, we're going to use some other tools here. So let me come back to this, and we're going to use a tool called Feroxbuster. Feroxbuster is a fuzzing tool, meaning that we use it to send lots of inputs to a website and then observe the outputs really fast. So I'm going to supply the tac URL flag, and I'll just give it our facts.htb. And that's all that we need to get started with this using the default scan. So you can see that what it's doing here is it's going to go through our directories list that it supplies automatically, and it's going to take every single entry in this word list and apply it to the site and see if it gets a response code back. So you can see, let's see, we get this admin and we get a 302, and it's going to redirect to this admin login. Hint, hint, we're definitely going to look at that in a second. You can see that we also get things like search, our dolphin fact page that we saw in there. And I'm just going to cancel this search because we've already found what we need in this case. So this http://facts.htb/admin. This is not something that we would have found by clicking around on the page. But let me go ahead and click that, or copy that rather. And let's put that into our browser here. You can see it redirects, as we would expect, to this admin login. And let me zoom in just a bit so that we can see that a little bit better on the video. So we have our login page. We don't actually know what technology is running on this web server right now. We know the web server technology, but we don't know what the service actually is. So if we didn't know what the service was, we could try some typical default passwords for that service. Like, for example, we might try something like admin and then the password of admin. No, I don't want to save anything. So username or password incorrect. That's not right. We might try like admin password. Okay, but that's also going to be incorrect. So that's something you can try. It's not always going to work. And in fact, if the site is configured properly, it shouldn't work, right? But what we can do on this site is we can actually create ourselves an account. Let's go ahead and do that. And we get our registration form. So I'm going to say my first name is test. My last name is test. My email is test at test. And we'll just use that HTTP, that invalid TLD like we discussed previously. Our username is going to be test. Our password, believe it or not, also going to be test. We'll confirm test. Now we have to do our CAPTCHA. So WRBR1. And am I a robot? I am not. Perfect. So the user has been created, and now we can log in as our user. So username test, password test. And you can see we're logging in. We have something that says, welcome to the admin panel of your site, which is not something that you want to see if you're logging in as a user that was just registered. However, if we look around, we can see that we don't really have any options over here. So it might just be the case that this dashboard just says, welcome to the admin panel, but we're not actually an admin in this case. Something that we can note is if we scroll down to the very bottom, we can see some version information. And let me just hide my face for just a second so that you can see the full version information. So down here, we have this Chameleon CMS. It's not spelled the same as chameleon, so I'm going to be saying it differently. I'm not sure how it's actually pronounced, but I'm going to be calling it chameleon. And then we have version 2.9.0 down here in the bottom right. So anytime we find a version of a software, we definitely want to search for it and see if there are any known vulnerabilities for this. So I'm going to open up a new Google tab. I'm just going to search chameleon CMS 2.9.0. I'll skip the AI overview because we all know how accurate that can be sometimes. And we can see that the first thing that comes back is this CVE. So this is a common vulnerabilities and exposures. This is the way that known vulnerabilities are cataloged, okay? This is just going to be the vulnerability mapping. So I'm going to check out this SentinelOne article down here. SentinelOne is a cybersecurity vendor, so they might have some information on what the actual vulnerability is. So open this in our new page, and we see that the CVE, the way that this is noted, is it's going to be 2026, which is the year that it was disclosed. This is going to be the UID, or the unique indicator, and this just tells us, this is unique, this is when it was found, and then CVE is just always the prefix. I do not need AI assistance. Thank you, though. Okay, so what is it? So this CVE is a path traversal vulnerability in the chameleon CMS that allows authenticated users. This is important to know because you want to know who can actually exploit this vulnerability. Because we have that test user that we just created, we are an authenticated user, so we're good here. It allows us to read arbitrary files on servers using AWS S3 storage. So AWS, or Amazon Web Services, has a storage version called S3, or that's what they call their storage. We'll be talking about AWS a little bit at the end of the video, but just know that this is kind of the underlying way that this vulnerability works. If we scroll down a little bit more, we can read a little bit more of an in-depth overview. So unlike the local uploader, the AWS S3 uploader does not validate paths with the valid folder path, okay? The flaw is going to be in this download private file functionality, and we'll take a look at that. And then interestingly, down here at the bottom, it's going to say this vulnerability bypasses the incomplete fix for CVE 2024, and then this number, okay? So 46987. So if we have an incomplete fix for a previous vulnerability, I think this one is going to be much more likely to give us insight into how the vulnerability is actually exploited. And that's just because it's been out for a little bit longer, okay? So I'm going to search for this CVE. And you can see chameleon CMS 2.9.0 path traversal. So I'm going to open up this exploit because this exploit is pretty easy to see kind of how the exploit is working. And then let me search for another one here. There's another one that we're going to use the actual exploit file. I might have to do GitHub as well. Nope, this is the one that I want. Okay, so we'll talk about each of these exploits a little bit. But let's jump into here and we'll see what this path traversal actually looks like. So this is an exploit. It's written in Python, and in fact, it is Python 3. If you're not familiar with Python, you can tell by looking here at the print statement. So if your print has parentheses, it's probably going to be Python 3, okay? So Python is a scripting language, and the cool thing about Python is that it's pretty human readable. So even if you don't know how to code in Python, you can kind of read through here and see what's going on, okay? It's mostly just like plain text. Now, we're going to scroll down here to this URL. So this is where they're constructing where we would access the vulnerable function, okay? So it's doing formatted strings. That's what this little F is. Don't worry about that right now, though, okay? So it's going to take our target URL, which is going to be our facts.htb site in our case. And then it's going to add this string to it. So this /admin/media/download private file. And if we remember, this download private file was the function that we saw back in the SentinelOne article. So download private file. And then it's going to do, this is called a request parameter. So the question mark file equals, and then we see this interesting .. thing here, okay? So this is a path traversal vulnerability. It's going to be going backwards in our file system. And let me show you what that looks like on our local file system. So let me open a new tab here. I'm going to use a tool just called Keys. And this just takes us into a directory that has some scripts in it. We don't need to worry about the directory. But if we use ls to list our directory, we can see that we have 2 more directories in here. I'm going to do cd to change directories into the linpeas one. And then if we print our working directory with pwd, you can see that our path here is this /user/share/peas/linpeas, okay? So if we were to ls the current directory that lists the files again, we can see all the files that are in this linpeas directory. Now, if we do ls .. tells the file system to go backwards one directory. So we're going to be listing the previous directory, which is what we saw up here when we listed out our peas directory. We can do that again with a .. So this is going to take us up from linps into ps, and then from ps into share. And there's going to be a ton of stuff in share. Then we can do the same again. And this is going to be r/usr directory. We can do it one more time, ... And this is going to give us our root or slash directory. Okay, so this is the directory at the very top of our file system. We can see things like etc, which we talked about before. We can see things like home, and we can basically navigate the file system using this ... slash method. Now, the interesting thing about the way that Linux reads these is that it doesn't actually care how far back you go. So if we do ls ... slash, and we just add more ... slashes, okay? So we're going to add 3 for no reason. You can see it's not actually going to go any further because, in fact, there are no further paths to traverse. So we go ... slash all the way back to the root directory, and then there's no farther to go. So this is useful when we don't actually know how many directories we need to go back. If we just want to go all the way back to the root of the file system, we can just add as many ... slashes as we think might be necessary, and it's going to kind of pad it out for us a little bit. So these extra ones don't hurt us. Now what we can do is, instead of going backwards, we can actually move forward into one of these directories. So let's see what's in the home directory, for example. We can see home. We have the home directories of 2 users. Brady's the user that I'm using right now. Callie's the user that comes default on the machine. We could go into home Brady. And this is going to be, you can see our Ferox Buster metadata file, and then some other folders, okay? So this is how the path traversal vulnerability works. So let's go back to our exploit. So where are we? Up here. It goes to admin media, download private file, supplies this request parameter of $file equals, and then this is going backwards out of the web servers directory and back up at some point to the root of the file system, okay? And after that, we can supply this requested path. So this is just going to say, okay, we're out of the web directories now. Let's go ahead and request any file on the system. So let's go ahead and try this out. So we can use this /admin/media/download private file, and let's put that at the end of our facts.htb, okay? Make sure you don't have 2 slashes here. You want just 1. So download private file. We're going to grab our parameter here, and we'll just use the amount of ... slashes that they have. So however many that is, we're going to slap that at the end. And then let's pull out a random file. So every system is going to have a file called the passwd file, okay? So we can pull it from the etc directory, and it's called passwd. And you can see that the file downloads here on our system. So let's go ahead and cat that out. Let me move back to my home directory because we don't need the ps directory anymore. So I'm going to cat or concatenate, which is just a way to tell Linux to read a file. And it's going to be in my downloads directory because that's how the web downloads things. And then it's called passwd. So if I read this, you can see we have information about the remote system, okay? Now, if I were to cat my local etc passwd file, passwd, you can see here's my user. And there are a couple components here to the passwd file. We'll talk about this a little bit more later, but just keep in mind that the passwd file is going to be unique to the system, and it's going to tell you what users are there, and it'll tell us a little bit more about what the user can do. So moving back to our web directory, now that we know that we can actually exploit this vulnerability, we want to kind of find a simpler way to do it. I'm going to jump over to this other exploit here. So this exploit is what's called a proof of concept, okay? So this is a script that's written for the purpose of security research, so that offensive security professionals can test systems and make sure that they are not vulnerable, or if they are, we can report them. And then so that admins can check their systems and see if they're vulnerable, okay? So if we scroll down, we can see they have cool information about the usage, examples, and whatnot. So this is a well-documented proof of concept. We're going to move into this Python file here, which we can tell it's Python because of the .py file name extension. And we're going to click into the exploit and read through it and kind of see what it does. Now, you want to do this before you run any exploit because there are potentially malicious exploits out here on the internet. So sometimes people will release an exploit that does malicious things. Like if a researcher runs it, it might send a callback to their server and steal their passwords or whatever the case may be. So we want to make sure and read through this file and just make sure that there's nothing spooky going on, okay? Now, it might be the case that we don't exactly know what Python is doing, but we can still read through it and just make sure that we don't see anything that looks super out of the ordinary, like a scary web address or anything like that. So let's just go ahead. I'll zoom in just a little bit so we can see a little bit better on the screen. So you can see it's going to import a bunch of stuff. It's going to run a thing called disable warnings, which comes from this URL lib3. So we don't really need to worry about this right now. It's going to create a class called Chameleon LFI. LFI stands for local file inclusion, and that's the kind of vulnerability that we're doing with our path traversal. So it's including a file from the local system, and that's how we were able to pull down the passwd file from our victim host, okay? So it's going to define a whole bunch of functions, and then down here at the end is going to be where we actually run stuff. So this if name equals underscore underscore main. So this function here just tells Python that if this file is being run directly and it's not being imported as part of another library or something like that, then do this stuff. You don't need to worry about that too much. Just know that this is going to be the way that we are running the exploit. So we are going to be doing the stuff that is down here. So after that, it's going to do something called argparse, which just parses out the arguments that we give it. So we'll give it some flags and information. It'll take those and it'll modify those however it needs to put them into the web request. It's going to store all of our input into this thing called args. And then it's going to create a new object called LFI, which does the chameleon LFI this class that was created up here. And it just takes the args and it formats them the way that the arguments want to be passed into the script. Okay. And then it's going to do if lfi.login. So it's going to check to make sure that we've provided valid login credentials. And then it'll do this thing called read file. Okay. So read file, we can see up here is defined. It does our path traversal thing that we saw before. And then this is the reason that I wanted to show that other exploit first, because this kind of, it doesn't really provide exactly with the URL that it's going to in plain text where we can see it. It kind of puts it all together for us. However, this exploit does work a little bit better in my opinion, because up here, instead of making us supply a token, which this exploit does, makes us give a authentication token. This one will actually just take a username and password. So what we're going to do is we're going to go back here and I'm going to click on this code dropdown and I'm going to copy this URL here. Now we're going to use a tool called Git. It is a version control software, meaning that we can go through different versions of this. You can see there are 4 commits and you can see like the history and whatnot. So we're going to use Git to pull down this file. So let me make another tab. And let me go back to 4. I'm going to rename this one and just call it passwd so that I know where that is in the future when we come back to it. We're going to use git, and then the subcommand that we'll use is called clone, and then I'll just dump that into there. Now this is going to pull it down from GitHub, and you can see it clones it into this directory here. So we can change directories into that directory name. And then if we list out our directory, we can see the files that were in GitHub, right? So right here, we've got our Python script and our README, which is all this information that we're looking at here. And here we've got Python script and README. So the way that we run a Python script is we can use Python 3, and then we just pass the script name. So I will copy that and paste it. And you can see it's going to give us a usage command, or a usage output, I should say. And then it's throwing an error because we have required commands that we're not using. But that's what we'd expect, okay? Something that I do want to show about Python files, which is kind of cool, is if we use the head command, that'll just show the top few lines of a file that we want to read. And then I'm going to paste that in there again. So at the top, we have this declaration that says, this is called a shebang or a hash bang. And it shows user bin environment env Python 3. So this is telling the file, if this is being run as an executable, use this interpreter, okay? So if we were to just run the file, and the way that we do that is we use the // which is current directory / this file. If we just run that file, right now we can't do that because we don't have executable permissions. So I'm going to use a chmod +x to add executable permissions. We'll talk about this a little bit more in the future, okay? So just hang on to that for a second. And then give it our file name. Now our file is going to be executable, okay? So if we do a // and then we provide our file name one more time, you can see that it turns blue just to kind of give us a friendly output that, hey, this is an executable now and you can run it. But if we run it, we get the same thing that we got before. So we don't need, like we ran it up here with Python 3, because of this declaration that they put in the beginning of the file, we can actually just run it just like this. All right, so now we want to go into our exploit and see what arguments we actually need to provide it. So our help command has this little -h at the front. This is telling us that it has longer help. So let's go ahead and click that. So this is kind of written in French, but we can still kind of figure out what's going on here. So no big deal. So we can see it's going to provide, we can do an optional, which is what these brackets are, -h, which we did to see the help. And then it wants a URL, which the TAC U, the TAC L for the logon or the username, TAC P for password. We can optionally provide it a TAC path. We can do TAC V to give it verbose output if we want, and then the file that we want to pull. So I'm going to use my up arrow to get back to here. We're going to get rid of our tac h and I'll give it a tac u. Our URL is going to be http://facts.htb. Our username is test. Our password is test. And then we're going to skip path because we're already in the path that we need to be in. However, if this was installed somewhere random on the web server, like if the Chameleon CMS was in a subdirectory called Chameleon or something like that, then we could provide that path. But we don't need it for our cases because it's just at the root of the website. Now, what file do we want to pull down? Let's pull down our etc passwd file. And you can see we get our output the same as the output when we downloaded it from the website. So if we come back to passwd, this is my local one. Remember, we were looking at Brady. But if we come up here, we can see users like Trivia. And if we come back to where our exploit ran, we can see this Trivia user. So now let's do a little bit of discussion about what the passwd file actually is. So like I said before, it lists out all of the users that are on the operating system. It's also going to tell us some interesting things about the users. So these are like the user's ID. It tells us the user's home directory. So this one is in /home/trivia. And then it'll have /bin/bash. So this is the shell that the user uses by default when they log in. Okay. So what we can do is we can actually do this again, or we can just cat out our previous file. That might be easier. So let's cat. It's going to be in /downloads passwd. So this is the file that we downloaded from the server earlier. And what we can do is called the pipeline operator or pipe. And what this will do is this will take the output from this command and it'll pass it to the next command. We want to read this, and then we're going to pass it to a tool called grep. So grep is the global regular expression print tool. It's going to process all kinds of data, and then we can tell it to give it back to us in different ways. We're going to grep for, we can use tac I to do case insensitive, but we don't really need to in this case because it's all lowercase. So we're going to do grep for the characters sh. Now, the reason for this is we want to look for the users that have a shell. So there are different users on here, like, for example, the root user, which is like the king of the castle. Okay, they can control everything on the system. We have like the www data user, which runs web services typically. But you can see that this is a service user and it has this user sbin no login. So this user does not have a shell associated with it. So we want to see which users have a shell associated with them. And the ways that we do that is these bin/bash. So the user shell might not be bash. It might be another shell called sh, or it might be something called zsh. But typically it's going to end with an sh. So we're going to use that. So if we run this, we get everything that has an sh in it. And indeed, we do get some false positives. So like this one has sh in the name. This one has sh in the name. But we'll just visually ignore those because we don't have a whole lot to work with, okay? So we can see our root user has the bash shell. And then we have two other users, Trivia with a bash shell and William with a bash shell. So these are going to be our two targets here, Trivia and William. All right, so now that we know what users we're targeting, let's take a look at what we found in our initial Nmap output, okay? We've got our web server, and then we've got our SSH, okay? So SSH, or secure shell, like we said before, is a way that you can make a remote connection to a machine and then get a terminal on that machine. Now, SSH is going to require some kind of authentication material, okay? So that can be a couple of things, one of which is the password, which we are not going to have. But another thing that we can do is we can try to find an identity file. So an identity file is going to be what we call an SSH private key. And this tells the server that we can authenticate using a key that we have. So it's, instead of just being something that you know, it's actually something that you have, which might be a little bit more secure in some cases. So I'm going to open up a new terminal here, and we can see what the SSH keys would look like. So if we cat out my home directory, and we can use this little tilde character, which is an alias for the home directory. And sorry, we don't want to cat that out. We actually want to list the files. You can see, like we saw before, just all the files that are here. If we supply the tac l command, it's going to give us a long listing of the output. So now we can see things like the permissions, who owns each of these files and directories. We can see when the file was last modified. Another flag that we want to add is the A. So this is going to show all files and directories, including ones that are hidden. So now you see we get way more of these files and directories. So this dot character in the front is going to be the way that we're going to indicate a hidden file or directory. And this is what A reveals for us, okay? So if we lsla, somewhere down here, we can see there is a .ssh folder. And if we are to lsla into home directory /.ssh, we can see what's in there. Now, I don't have any SSH keys on this system right now. This isn't a system that I typically SSH into. So let's go ahead and create one just for fun. So I'm going to use a tool called SSH key gen or generate an SSH key. And it's going to ask us some prompts, okay? So enter file in which to save the key. So homebrady.ssh, and then this ID underscore ed25519. So 25519, this is the encryption algorithm that it's going to use. And if we look back at our nmap output, when we're in our script scan, we can actually see it uses the ed25519 algorithm. So this is cool information. But this is going to be what it will save it as default. So in the parentheses, it's telling us, hey, if you don't tell us what file name, it's just going to save it to this. So let's do the default file name. It's going to ask for a passphrase. We're going to leave it empty because we don't want a passphrase right now, but just think about that later. Enter same passphrase again. So confirm your passphrase. And then it creates a file for us. So now if we scroll back up and we lsla our .ssh directory, you can see that we now have this file, like it said it was going to create. And we also have a .pub. So this is the public key, which the way that public and private keys work is that everyone will have your public key. And that's how they're going to verify that your private key is valid. Only you should have your private key. That's why it's called a private key. So these two are going to be mathematically linked using that algorithm that we saw back up here. But they should be non-reversible. So they shouldn't be able to take the public key and get the private key from it. You're going to have to supply the private key, and that'll tell the public key or the service that is using the public key that you are the valid person that should authenticate. Now, something else that we should see are the permissions on the file. So we have 3 sets of permissions on the Linux file system. You see the D indicates that this is a directory, so we'll ignore that. But then there are 3 groupings, okay? And there are 3 possible permissions. We have read permission, write permission, and execute permission. So the 3 groups are going to be the owner of the file. So in this case, for the public key, the owner of the file can read and write. No execute because this is not an executable file. And then our listing here will tell us who the owner of the file is. So this Brady user is the owner of this file. We can see the next is going to be the group permissions. So if you're in the group here, which is also called Brady in my case, you can only read, not write. So if you are in the group, but you are not the owner, you can not write, but you can read. And then this third set of permissions is going to be for everyone else, okay? So if you are not in the group and you're not the owner, this is what you can do. You can read this file, all right? So if we do try to read that file, so let's cat home /.ssh, and I need my dot, there we go, SSH, and then ID. We'll cat the .pub file. This is what our public key is going to look like. So it's going to tell the encryption algorithm that we used. This will be a unique string here, and then it's going to tell what user we created it as, all right? If we cat out the private key, it's going to look like this, okay? Begin open SSH private key, and then end, and this is fun math stuff on the inside. Now that we know where SSH keys are stored and what they look like, let's see if we can use our exploit to pull down one for one of our users, okay? We can see that our users are root, which we are unlikely to see because typically these labs, you're not going to escalate directly to the root user. You'll escalate to a low-level user on the machine, and then you'll escalate to root from there. Still valid in a real environment looking for root SSH keys, but in this case, we're going to target the Trivia and William users. So let's go ahead and get back to our exploit. So instead of pulling down etc passwd, we're going to go into this Trivia user, because that's our first one, into their home directory, which we can see is /home/trivia. We'll do /home/trivia. And then we'll go into the .ssh directory, and we'll see if we can find a file that matches that default file name. So where did I have this before? So right here, where it says .ssh ID underscore ed25519. This is going to be the default file name. So let's see if maybe they saved something that just had the default file name on it. Okay. So let's see if we can pull one of these down. And in fact, we do. Okay. We get some output here. It says begin open SSH private key. So what we can do is we can use the greater than sign to redirect this to a file. So the greater than sign just tells it, take the output of this command and just write it to a file. And we're going to call this file, let's put it in our home directory. And we will call it trivia underscore, and then we'll keep this format down here at the end. So trivia ed25519. And now we can see that file is at home/trivia ed25519. And if we cat it out, we have that key. Okay. Now let's go back and talk about the permissions that we saw on this file before. So when we open up our permissions for the keys that we created, we have this read and write permission. So this is the default permission that we want to see on a private key. And in fact, if we try to do stuff with the private key, it will not work. unless it has those permissions. So let me open up a new tab just for messing with this private key. So if we see our private key name is this trivia ed 25519, we can use our SSH keygen command that we used before, and we can provide it with the TAC Y flag. And this just tells us that we're going to be inputting a private key and outputting the public key. So we can use the TAC F command to indicate that we're giving it a file name, and then that's the file. You can see here, it's not going to load it. It says bad permissions, okay? Permissions 0664 for trivia ed 25519 are too open. So if we ls LA on our trivia file, we can see that the current permissions have this read, write, execute, read and write, and then all read. So this is what we're saying when we see it's too open. And this is the permission mask. So in the Linux file system, we have three possible permissions. Okay, we have read, we have write, we have execute. Each of these has a numerical value associated with it for this masking scheme. So read is worth 4 points, write is going to be worth 2 points, and then execute is going to be worth 1 point. And the addition of these is going to tell you which ones they have. So if it has read and write, it'll have 6. If it has write and execute, it'll have 3, and so on and so forth. So we can see we have read write, which is 6, read write, which is 6, and then read, which is 4. So that's what it's saying when it's saying 664. Now what we need for the proper SSH key permissions is 600. So we're going to use the chmod command or change mode. And this is how we modify permissions on the Linux file system. We can just supply this mask to it. So chmod 600, and then we'll give it the name of the file here. So trivia ed 25519, and I'll just put this whole command in the notepad and then paste it in here. So it's not giving us any errors, so we can assume that it worked. And if we LSLA again, we'll see that we can read and write only for the owner of the file. Now, if we do our SSH keygen command again, so it's going to ask us for a passphrase now. Now, the issue here, remember when we created our SSH key file, we didn't actually supply it with a passphrase. But this one, when it was created on the system, was created with a passphrase. We're not able to do anything with this SSH key until we decrypt it. And to decrypt it, we would need to know what the passphrase is. Now, luckily, we can just control C out of that. There is a tool called SSH to John, and it's part of a password cracking suite called John that will allow us to extract a hash of the password and write it out to a file, and then we can try to crack that hash. So we'll talk about hash cracking in just a minute, but the way that we would do this is we would do SSH to John. We would give it the file here, and this is going to give us what's called a hash. Just for completeness, I'm going to write this to a file, and then we'll talk about hashes. So SSH to John trivia, and we'll call this hash.txt. So if we cat out hash.txt, you can see it's the same thing as when we ran this command before. So let's talk about what a hash is for a second. So a hash is just a mathematical representation of a file. So if we were to, for example, just echo out, let's echo hello. You can see we echo hello. Now, if we use our pipeline operator again, we give it the pipe, and then we say MD5 sum. So MD5 is just the hashing mode that we're using, and sum is the end of checksum. So checksum, you can think of as another name for a hash right now, but this is just going to give us a representation of the file or of the contents. So echo hello, and then it'll give us the contents of that. You can see that using the MD5 format, hello looks like this, okay? If we were to change this, we could call it hello1. Now you can see that this is completely different, right? The B is still the same, but now we have 5273 instead of 1946. Everything in this is different. Now, interestingly, if we go back and we change this back to just saying hello, you can see that we're going to get the same thing that we got before. So a hash is going to be the same every time. It's what's called a one-way function. So a hash only works one way. You can only hash, you can't unhash. But what a password cracking tool will attempt to do is it'll attempt to take a hash and run a whole bunch of inputs against it and try to see if it can create this hash again. So if this hash is the only thing that we have, we can try to say, okay, well, let's hash hello with MD5 sum and see if it comes out to be the same number. And if it does come out to be the same number, we know that that is the same passphrase that was entered. Let's get back to where we were with our hash.txt. We're going to use the tool called John. We're going to provide it with, oops, that's not what I wanted. We'll provide it with hash.txt. And then I'm going to give it a word list. The reason that we give it a word list is so it's not just trying to brute force through everything. So a word list is what it sounds like. It's just a list of words. And we can run through every word in that list and try to hash it and see if the hash comes out to be the same as the one that we provided. Okay. So we'll do word lists. I've got a word list stored at user share word lists and then rocku.txt. And I'm going to run this while I talk about what rocku is. So you can see it loads the hash and it's going to attempt to crack it. Should take about 2 minutes. So rocku was a security breach back in 2009. Rocku was a company that made widgets for companies like Facebook and MySpace. So they had all kinds of passwords stored. They were breached, and then all the passwords were disclosed on, I think it was on the dark web. So the rocku word list is all the passwords that were found in that data breach, and it is commonly used as a cybersecurity word list. So to crack passwords, we're going to provide it a word list like we said, and it's going to take everything from the rocku data breach, and it's going to hash it and see if it finds a match. I'm going to do a quick time skip here so that you can see what the result is. Okay, so our result just came through, and you can see that this SSH key, the trivia.whatever, cracks with the passphrase of Dragon Ball Z. Okay, you can see it took just about 2 minutes to crack, so that little time skip was just to save a bit of time on the video. But now, if we scroll back up to our SSH key gen command, where we tried to input this file, when it asks for the passphrase, we're going to enter Dragon Ball Z, and you can see that now it's going to output the public key like we wanted to before. So if we were to SSH to trivia at facts.htb. Remember, we don't need to supply HTTP. We're just supplying the host name. And then we can use the TAC I for identity file and give it trivia ed25519. You can see it's going to ask if we want to connect. We'll say yes. It's going to ask us to enter the passphrase. So I'm going to make sure that that is in my clipboard and then paste it again. And now you can see we are logging in. So we can say, who am I? And it'll tell us that we are this trivia user. All right, so we've gained initial access to the machine. So now we can do things like try to find what's called the user flag. So on labs like Hack the Box, we'll have what's called a user flag, which shows that we've gained access to a low-level user, and then a root flag, which shows that we've gained access to the root, or we've fully compromised the machine. So right now we're going to look for the user flag. So if we do pwd for print working directory, it'll tell us that we're currently in the /home/trivia directory. Typically, these files are going to be stored here. So let's do an ls and see if we can see anything. And we don't get any results. If we do our ls/la, you can see stuff that we saw before, like the secret.ssh directory that we were looking at before, but there's no flag in here. So let's see if the flag might belong to another user. So let's ls ... which should take us back from trivia into the home directory. And we can see the directory of William, which was the other user that we saw in our passwd file up here. So let's see if we can ls/home/William. And in fact, we can. So we see user.txt, but are we able to read that? Well, let's do our ls/la, and we can see everything in here, including our user.txt, and the permissions on here for everyone is read. So we should be able to read this file. So if we cat out /home/William user.txt, we can get this flag. So this is just a hexadecimal string. It doesn't mean anything, but we would just paste this into Hack the Box and tell them that we captured the flag, and they would give us fun points and tell us that we're super cool. Okay, so this is the initial compromise of the machine. There is a second parallel method that we could have used. I think it's a little bit more difficult to explain. So I'm going to show this at the end, but for the purpose of continuity, I'm just going to proceed right now as though we've first compromised the machine, and now we're going to move on and see if we can proceed to the root. So the first thing that we want to do when we compromise a machine is see what our user can do, okay? So what we can do is run the groups command and see what groups we're in. Right now, we're only in the group trivia. So this is just a group that contains the user. So this doesn't really actually give us anything. However, there's another command that we want to run as soon as we run on here. And that is the sudo command, or switch user and do. So let me do a tac help. And sudo has a help output. But you can see what sudo does. It executes a command as another user. So this will allow us to switch to somebody else and run a command. If we do it by default, it'll switch to the root account if we're able to. So this can be a helpful privilege escalation vector. Now, if we see down here, there is the tacl command or tac list if you want to do that. And that will list the user's privileges or check a specific command. And we can use 2 L's for a longer format. So if we do sudo tacl, and we'll do 2 L's just for the longer format for now. Typically, once you've done it a couple times, you can just use 1 L, but we'll do 2, and it'll tell us everything that we can do. So we have an entry. It says run as users all, which means that we'll be able to run whatever this is as the user of our choice. So in this case, it'll be the root user. The options command, we have the exclamation point, which in computer speak means not, and then authenticate. And then our command is this user bin factor. All right, so if we just ran it with one L, it would look like this. So it'll say user trivia can run the following commands on facts. All, which means all users. No password, which this is actually pretty helpful because we don't actually have the password for the trivia account. Remember, we just have that SSH key. And then user bin factor. So we can run factor as root. But what does factor do? We don't really know. So let's see if we can find out. Let's just run it not as root first, just to see what it does. So we can run it as factor. We can run it as user bin factor. It doesn't really matter. So it's taking a little bit of time. And then you can see it outputs all of these facts about the system. Okay. So this is why the machine is called facts. That and a combination of the trivia stuff before. So that's cool. Good world building, in my opinion. But this is basically what this does. And this doesn't really look like it's super exploitable, right? But what we can do is we can check there is a repository of common privilege escalation vectors called GTFOBins.org. There we go. So let me zoom in just a little bit. So GTFOBins is exactly what it says. It's a curated list of Unix-like executables that can be used to bypass local security restrictions in misconfigured systems. So what does this mean for us? If we have something that we can run that is on this list, we might be able to execute it as a super user or use it to escalate our privileges. So let's scroll down a little bit. We've got this filter functionality, and let's just type in factor. And we do have an entry for this. So if there wasn't a privilege escalation vector, we wouldn't see it, but in our case, there is. So we'll click on factor and we'll see what it can do. So it's got this inherit functionality. So this executable can inherit functions from another. So we'll see this comment. So the first .rb file in the path2dir directory will be executed. So .rb is the file extension name for Ruby, which is another scripting language, kind of like Python that we looked at earlier. But factor is going to run the first Ruby file in the specified directory. So this is what we can do to inherit functions from Ruby and escalate our privileges. Now let's see how we would run this. We can click between unprivileged and sudo if we want. In this case, it's going to be the same. But if there are environment variables involved, they can be passed using sudo. And this is how we would do an environment variable. So variable equals value, or exported then use the sudo tac e. So this is how we would try to run this. So factor lib path2 directory, and this is where we're going to store this, factor. So let's go ahead and throw this in our notes for just a second. We'll be coming back to this. And the functions, it says it inherits from Ruby, thus possibly granting the following functions. And we have a shell function. If we have shell, we definitely want to use it because this will give us a shell as the root user, which allows us to execute commands and basically will give us a full compromise of the machine. So let's go ahead and open this up. I'm going to open it in a new tab, and we will look at how we would do things as Ruby. So we have sudo. This is going to be executing as the sudo user because it inherits the permissions of the previous function that we ran. And this is how we would run a shell. So Ruby tac e for execute. And then in these quotes, we have exec/bin/sh. So let's move this into our notepad. I'm going to change this from sh to bash. That's just because I think bash is a friendlier shell. If you only had sh, you could use sh and it would be just fine. But I'm going to, for my uses, change this to bash. Now we need to be able to write this to a file because remember it said the first RB file in the path2dir directory will be executed. And since this is a very simple string, we can just use echo to write this to a file. So if we do echo exec/bin/bash, and I'll show you what's wrong with this in just a second. Let's test it in our terminal. You can see that this is going to look a little bit different than what we put in. So we have echo exec, and then we have quotes /bin/bash. Now what bash is doing is it's interpreting these quotes as saying, oh, just give me exactly what's inside of the quotes. So it does exec, and then there's a little space because it's doing a quote, and then bin bash. But we don't want to do that. We want it to have the quotes in there when we echo it out. So the way that we can do that is we can use single quotes, and it's going to give me an extra one that I don't want. But we can wrap the whole thing in single quotes. So echo exec bin bash. And this will tell bash to just interpret this as literally what is inside of it. Okay, don't do any interpretation. Don't do any additions or subtractions. Just give us exactly the string that we echoed. So if we run it like that, then it's going to exec/bin/bash. Okay, so what I'm going to do is I'm going to press the up arrow key to bring that back. And then we're going to write this to a file. And we'll just call it factor.rb because remember we need to write a Ruby file. And now if we ls, we can see that we have our factor.rb. If we cat out factor.rb, we can see we have our exec/bin/bash. Okay. So our file is set up. Now we need to find a way to execute it. So our factor lib path2 directory, remember it's going to run the first RB file in our directory. So we'll change path2 dir to /home/trivia, and then it just runs factor. Now we need to run sudo first because we can run as the super user. So let's copy that and paste it. And now it's going to tell us you're not allowed to set the following environment variables, factor lib. So this factor lib environment variable is not compatible with our current sudo permissions. But luckily, we do have a second option that we can do here, which is not using an environment variable. And it's just this string here, factor tac custom dir equals path2 directory, and then this little X at the end. So let's put that in our notepad. Let's modify this so that our home/trivia directory is the custom directory. And then I'm going to put a slash at the end just so that it matches that syntax exactly. And then we'll run this with sudo. So we'll put sudo at the front. And let's see what we get now. So now you can see we get a root shell. So the root shell is commonly indicated using this hashtag or octothorpe or whatever you want to call it, waffle, if you will. But if we run who am I, we can see that we get root. So now we can print our working directory, and you see that we're still in the trivia directory. So let's change directories to the root directory's home directory. And if we do a pwd now, you can see that the root directory's home directory is this /root directory. If we ls, we can see we have a root.txt. And if we cat that out, we can see this is our hexadecimal string that gives us the points for the full compromise of the machine. Okay, so this is going to be the full path through factor, the easy way. Now I'm going to show the other method that we can use for initial access. So if we go back to our search about the Chameleon CMS, you can see there is also this mass assignment vulnerability in Chameleon CMS 2.9.0, which is what we have. So let's see if we can find an exploit for that. This is the CVE record. So mass assignment, like we saw before, CVE 2025-2304. Let's go ahead and click into that real quick. And it'll tell us privilege escalation through mass assignment exists in Chameleon CMS. When a user wishes to change his password, the updated AJAX method of the user controller is called. The vulnerability stems from the use of the dangerous permit method, which allows all parameters to pass through without any filtering. So we definitely want to make sure we're able to filter parameters. But if we're not, we can do some special things with it. So let's see what this would look like. Let's grab our CVE 2025-2304, and let's see if there's an exploit for this available. I'm just going to do exploit GitHub. And this is just an advisory, so we'll skip this one, advisories, and we have a proof of concept right here. So let's open this one up. And when it loads, we can see this is a privilege escalation in Chameleon CMS, less than 2.9.1. Now, this exploit was actually written by a member of my Hack the Box team. So this did not exist when this machine came out. So this is pretty cool. But it does show us how the privilege escalation in the CMS or content management system is actually accomplished. So let's jump into the exploit file, like we were going to read through it and make sure everything's okay. And you can see we don't need to read all of what it does. You know, down here it does if name main. It runs this main function, which is defined up here, define main. So it's going to take some arguments, do some stuff with the arguments, print out some results. But the cool thing that we want to see down here is right here, the data that it sends. So it's going to send a post request, and it's going to have this data in it. So it's got password. You can see that's in a bracket. Password confirmation, which is like when you try to change your password and it says, okay, confirm the password so that you have the two that are correct. And then this one, password role admin. So when the user is changing their password, they can actually supply this role. And if we say that our role is admin, then it'll treat us as though we are an admin. So I'm going to open up a tool called Burp Suite. Burp Suite is a web proxying tool that we can use to capture our responses and see what's going on between the web server and us. And then we can also modify our responses and send different requests. So I'm going to jump over to proxy and I'm going to open Burp's browser. So this will give us a browser in which we can capture our requests. We don't have to configure anything else, which I think is really, really nice. So if we go back to our admin panel, let's just go to facts.htb. It's probably going to make us log in again. We'll do admin. And let me zoom in just a bit. Oh, that kind of full screened it. That's nice. So we'll do test and test, which is our username and password from before. No, we don't need to save that. Let's full screen this so that we get the full experience, okay? So this is what we got before. So we've got our copyright statement. The version is down here behind my face. And then we have the same thing. It says, welcome to the admin panel, but we don't really have a whole lot here. Let's go into our profile. And you can see that there is, we've got like a user ID. We can change our photo. But most importantly, down here, we can change our password. So if we want to enter a new password of new pass and new pass, if we go to Burp Suite and we turn intercept on, now we're going to be intercepting anything that we send. So if we do process, oh, maybe I didn't enter the same value. Let's try it. Okay, I guess I didn't enter the right thing. Let's do test 1. Test 1. Okay, now it's not yelling at me anymore. We will process this request. And this is going to be a little bit hard to see. I'm not able to make it any bigger. So you can see we're sending a post request, which means we are sending data to the server, not just getting data from the server. And this down here is the statement that we're sending. So this method patch authenticity token, which tells us that we're logged in. And down here is this password. And you can see it's got the %5b and %5d. This is just URL encoding. So this is just the way that web services handle special characters. You can see over here in our decoded window, we have password and then in brackets password. Now remember, this is what we saw in our exploits, which was over here, the password confirmation, and then password role. So let's get back to our intercepted request. We can see the password. Down here is the password confirmation, but there's nothing for the password role. So let's go ahead and copy this one and we'll just add it in ourselves, okay? So we don't want it to be password confirmation anymore. So inside of this 5b and 5d, we're just going to make this password underscore role. I believe that's the syntax. Let me just double check. No, okay. So it's not password role. It's just the word role. So let's change it to role. And we can verify this just by hovering over it. And let me get that ampersand out of there just to make it look nice. So password role equals, and right now we have it set to test 1. But let's set it to admin. So this is going to be the key part of our exploit. We're telling it that our password role is admin. So let's go ahead and forward this request, which will send it to the web service. And then we can turn our intercept off. And you can see we have action completed successfully. So let's close out of here. Don't need to save the password. Thank you, though. And we're going to log out so that our changes are reflected when we log back in. So now our username is going to be test. Our password is test1 because we changed it to test1. No, I don't need to save that. So now, instead of just being a regular user that has this welcome to the admin panel site, we've actually successfully exploited the vulnerability and we have escalated to an admin on the content management system. So from here, we would have to do a little bit of looking around, but to skip over that, we would just go into settings and we go to sites, I believe it is. Nope, maybe it's general site. Yeah, it is. Okay. So if we look through these settings, if we go to file system settings, you can see here we have save files in AWS S3 is checked. Now, if we remember our description of the other vulnerability, it says that it uses AWS S3, which is Amazon's cloud storage provider. And you can see that our site is using that in Chrome here. So it also gives us the AWS S3 access key and secret key. So these should be protected, but since we're an admin of the site, we can see them. So we can actually use this to interact with their cloud storage. You can see we have an S3 bucket name, a region, and then we have the bucket endpoint. So this is where we said we were going to talk about localhost. So localhost just tells the web server to interact with itself. It's that 127.0.0.1 IP address that we talked about at the very beginning of the video. You can see it uses this colon to denote the port, and it's on port 54321. Let's just copy this into our notes real quick. Since we are on a remote system on our attacking machine, we're not actually going to be targeting localhost. We're going to be targeting our machine's IP address. So if we do another nmap command, like nmap, our IP address, and then we can do the hack p to specify a port. Let's go ahead and run that and see what we get back. Okay, so we do get an open port. So this did not show up in our initial scan because it's not part of the top 1000 default ports. So this is kind of a hidden port, if you will, unless we specify to look for ports that are in a different range. But this port is open. This is where the AWS storage is running. And we can use the AWS command line interface, or AWS CLI, to interface with that S3 storage. I'm going to run AWS configure. Okay, so it's going to ask for our access key, and we can get that from right here, S3 access key. I'll paste that in. It's going to ask for our secret access key, which again we have here, the AWS S3 secret key. Okay, our default region name doesn't matter, so we'll just set it to the default of none, output format, default of none. And now our AWS CLI is configured to use those credentials that we grabbed earlier. So the way that we would use this is we would use AWS, and we would have to target our endpoint URL. If we did AWS normally, it would actually just send it to Amazon Web Services, but since this is running locally, AWS isn't going to know who we are. So we're going to use the tac endpoint tac URL, and this flag will let us specify our own place to send these requests to. So this is going to be our localhost 54321, but instead of localhost, remember we want our IP address. So we will do that. And then we can do things like S3 LS. And we get two, these are called S3 buckets. Buckets are just what S3's cloud storage directories are called. So we have the random facts one, which is what we saw here. So AWS S3 bucket, random facts. Then we have another one called internal. So let's pull up our command again, and let's S3 LS into S3 : //. So our scheme now is going to change. It's not going to be HTTP. It's going to be S3. And then we'll look at random facts. And you can see in this bucket, we have stuff like animalejected.png. This is like storage for the website that we saw before. So this isn't really interesting to us, but maybe what's inside of this internal bucket? Let's get rid of random facts and type in internal. And now we can see, hey, this looks like all the hidden files inside of somebody's home directory, right? So remember before we looked at .ssh. So let's try looking at that again. So .ssh. Okay, sorry, I actually need to add another / there at the end. That was the issue. Okay, and now we can see what's in this .ssh directory. So we have our authorized keys file. We have our ID ed25519. So this looks pretty familiar, right? This looks like the trivia user. We wouldn't know that for sure, obviously, because we hadn't done the other exploitation method. But what we could do is we could do an S3, instead of ls, we're going to do an S3CP. So I'll grab this file name and paste that here. And then S3CP. And then I'll just do a dash at the end just to say to write it to the terminal instead of trying to move it somewhere. CP is for copy, by the way. Okay, and now you see we have our OpenSSH private key. So what we could do here is we could write this to a file, and we will call it AWS SSH key. So now we would be able to do our SSH key gen like we would before. And we could do /y to tell it that we're going to input a file and we want the public key out. And the reason for this is because we only have the private key, but we don't actually know right now what user corresponds with this private key. So we'll do the tac f like we would before, AWS SSH key. And you can see we have bad permissions. So we're going to change the mode to 600 on AWS SSH key, and then we will run it again. And now we're getting the same issue as before, enter the passphrase. But we're going to enter the passphrase that we already found just to save ourselves a step. Here, obviously, we would crack the password and get the Dragon Ball Z. But here it's going to tell us the public key. So the SSH ed25519, it gives us this string. And then right here, it tells us trivia@facts.htb. Now, this has actually been scrubbed from the authorized keys file. So if you were doing this method, you would have to decrypt the file to get that information. So like if we do CP, and let's not output to a file, let's just do authorized keys. So authorized keys is a file in the system that tells you the public keys that are able to be connected to with a private key. And you can see this has actually been scrubbed out here. So they manually modified this and made it so it didn't say trivia@facts.htb. All right, so that's the end of the parallel AWS route. So you could either blindly pull the .ssh directory and try to find a key if you kind of know that those directories already exist. Or if not, you could try to do this privilege escalation vector in the Chameleon CMS and try to go through AWS. But that does bring us to the end of the video. So we have successfully exploited facts on Hack the Box. Hopefully you were able to learn something, and I will catch you in the next video.